Okay, so we really want to get the most out of your PRAC report for our light wavelength experiment. So we're going to go through a few tips that should hopefully get you the best result possible. The first thing we need to do is to check that your results are accurate and that they're acceptable. So you should have 5 results, each with a varying L value. So that's the distance from the diffraction grading slide that you used until the screen or the piece of paper that you're recording your light on. So these all values need to be in meters. So if you used centimeters or millimeters or whatever to record your distances, you need to convert those before you put them into any formulas. You should also have 5 corresponding values of delta Y. Now delta Y is the distance between the bright fringes of the laser that we found on the screen or the paper that you are actually looking at. Once you have all of these and they're all converted into meters, you're ready to go. The next thing we have to make sure we have is, once we have 5 results, we need to make sure we have a table of data. So our data table needs to have appropriate headings, so to show what we have in each of them, so our delta Y value and our corresponding, or our L values and our corresponding delta Y values. We also need to make sure that we've got enough space for 5, and if you're going to calculate an average or so on for each of your values. The next thing we have to do is calculate our D value. Now we use the formula D is equal to 1 over N, where N is the number of slits per unit of area. So you need to use the number that was on your slide and this formula to actually work out what your D value is. Make sure that you convert it to units. Now, once we've done that, we can actually plot our graph. And it's really important to know that we are using an XY scatter graph, and we have to have our L values, or our distance between the slide and the screen is on the bottom or on the x-axis, and then our corresponding delta Y value is our dependent variable, so that goes on the y-axis. Once we've done that, we then need to calculate the error percentage. So we use the formula that's on your task sheet, so it's the calculated wavelength minus the actual wavelength divided by the actual wavelength times by 100. So that should give you a percentage of error. And now the actual value of a red laser is 650 nanometers. Once we have all this, we now have to actually write up our discussion. So here we compare our value for the actual wavelength to the value that we calculated. Now in science and engineering, a percentage error of less than 15% is considered acceptable. So we need to try and explain any discrepancies and account for random or systematic errors if they're there. So we need to know what random and systematic errors are, and then be able to comment on any procedures, the procedures that we used, and make possible improvements. Now, in order to get a good grade, we need to suggest multiple improvements to how we could improve this experiment for next time. And lastly, we have to summarize our findings, and it's normally 2 to 3 sentences, and our entire PRAC should be no more than 600 words, give or take 50. So if we do all of this, that will probably enable us to get a C for our report. So it's really important that we go above and beyond what I've just got here. So things you could include are like error bars on your graph. You could include in-depth analysis or referring back to some different formulas. Anything that's going to try and tell me why what has happened has actually happened. And if we do all of this, you'll start to improve your grade from a C level up to a B or even an A. So remember that I like to see pictures if you've got any pictures during the PRAC, and if you'd like to see have a draft of your work looked at, please make sure that you send that through to me by tonight, and the final due date for our experiment is Monday. So let me know if you have any questions, but hopefully this will help you out.
Created using Powtoon.